Good morning, champs. Before we start solving complicated engineering problems, we need to understand the basic idea behind statics. The good news is that most statics problems follow exactly the same workflow. Once you understand that workflow, many exercises suddenly become much easier. Let's start with the most important concept. A force is simply a push or a pull. When you push a box, you apply a force. When you pull a rope, you apply a force. And when gravity pulls an object toward the earth, a force is acting as well. Forces are measured in Newton. A force has a magnitude, a direction, and a point of application. We usually represent forces by arrows. But forces do not only move objects, they can also rotate objects. This rotational effect is called a moment. Think about opening a door. If you push near the hinge, the door is difficult to open. If you push at the handle, the door opens easily. The reason is that the distance from the hinge is larger, creating a larger moment. The moment is equal to the force multiplied by the perpendicular distance from the pivot. Now let's talk about statics. Statics studies structures that remain at rest. If a structure is not moving and not rotating, it is in equilibrium. For equilibrium, three conditions must be satisfied. The sum of all horizontal forces must be zero. The sum of all vertical forces must be zero. And the sum of all moments must be zero. These are the most important equations in statics. Now let's solve our first problem. We have a beam supported at 2 points. A force of 1,000 Newton acts downward in the middle. Our goal is to determine the support reactions. The first step is always to draw a free body diagram. We isolate the beam and replace the supports by the forces they can exert. The pin support provides a horizontal and a vertical reaction force. The roller support provides a vertical reaction force. Next, we apply the equilibrium equations. Let's start with the horizontal direction. There are no horizontal external forces acting on the beam. Therefore, the horizontal reaction force must be zero. Next, we calculate moments about point A. The reaction force at B creates a counterclockwise moment. The external load creates a clockwise moment. Setting the sum of moments equal to zero allows us to calculate the reaction force at B. We obtain a value of 500 Newton. Now we use the vertical force equilibrium. The upward forces must balance the downward load. Substituting the value we just calculated gives a vertical reaction force at A of 500 Newton. We have now solved the problem. The horizontal reaction force is zero. The vertical reaction force at A is 500 Newton. And the vertical reaction force at B is also 500 Newton. Before finishing, let's perform a reality check. The load acts exactly in the middle of the beam. Therefore, it makes sense that both supports carry the same load. And this brings us to the most important lesson of this video. Almost every statics problem follows the same 4 steps. Draw the free body diagram. Replace supports by reaction forces. Apply the equilibrium equations. And finally solve and check your result. Master these 4 steps, and you will be able to solve a large number of engineering problems.